In this video, we want to discuss a special type of integration by parts integral. I call it a wheel integral, and you'll see why I call it a wheel as I do it. But this is a little bit unusual. So I felt like it was important that I do this example so that you could see how it works. So we look at our integrand, which is e to the x sine x. And in this particular case, it's not really clear what your u and what your dv should be, because both of these functions are easy to take the derivative of, and both of them are also easy to find the antiderivative of. So I'm just going to make a choice. So I'm just going to let u be equal to sine x, and I'm going to have dv be equal to e to the x dx. And as you know, we need to differentiate the u. So we're going to get du is going to be equal to cosine of x dx. And we need the antiderivative of the dv part. The antiderivative of e to the x is just e to the x. Now let me put these together. I'm going to rewrite my original question, which was e to the x sine of x dx. And now I'm going to apply the integration by parts formula. So that should be u times v. I'm going to write the e to the x in front of the sine x minus the integral of v, which is e to the x, du, which is cosine of x dx. Okay, so now take a look at this integrand that we have to calculate next, this integral. When I look at this integral and I compare it to the original problem, it looks just as difficult. Doesn't look like we've made any progress. Nevertheless, let's keep going. Let's do integration by parts again. This time, I'm going to have my u be equal to cosine of x, and I'm going to have my dv be equal to e to the x dx again. So I differentiate the u. My du becomes negative sine x dx, and I find the antiderivative of dv. The antiderivative of e to the x is just e to the x. And this time, when I write down what my result is, I get e to the x sine of x minus, I'm going to have my uv, so I'm going to write that as, I'm going to write the e to the x first. That'll be e to the x cosine of x. And then I have minus the integral of v du. Now, at this point, I want to mention that we had a negative here already. And then my integration by parts formula also has a negative, but when I distribute this across, that's going to make this a positive. So that's quite important. I'm going to actually highlight this just so that you don't forget about the sign, because a lot of times students mess that up. They forget to distribute the negative. Okay. So I had minus the integral of v du. So my v was equal to e to the x, and my du is negative sine x dx, like this. Okay, so just to reiterate, the formula goes uv minus the integral of v du. This negative got distributed, so the negative uv, and then the minus integral of v du, that made this a plus, but our du has a negative here. So let me write one extra step here. We're going to get e to the x sine x minus e to the x cosine of x minus the integral of e to the x sine x dx. So we have something super interesting happening here. When you look at what's left to integrate, that's exactly what my original question was. But it was super important for us to keep track of the signs. The fact that this is negative is great for me because what that means is I can add this to both sides. So I will add integral of e to the x sine x dx to both sides. When I do that, what do I get? Well, on the left-hand side, I'm going to have 2 times the integral of e to the x sine x dx. And on the right-hand side, I'm going to have e to the x sine x minus e to the x cosine of x. Okay, so to get the answer that I want, I simply divide both sides by 2. Divide both sides by 2. And when I do that, I'm going to get my answer, which is the integral of e to the x sine x dx is equal to 1/2 e to the x sine x minus 1/2 e to the x cosine x. Let's tack on a plus c because an antiderivative gives a whole family of functions. And I'm going to highlight my final answer there. All right, everybody, this is the classic wheel integral example. Take care.